Okay, today I have the great pleasure of speaking to an old friend. His name's Jim Coker. He's from 512, the makers of Numerology, and now some new magic that we're going to be talking about. And we've already spoken with him in the past, so I will refer you back to that podcast if you want more information about his background. This time we're going to talk about some of the newer things that he's been working on, and I'm really anxious to get into it. So with that, with no further ado, let's talk to Jim. Hey, Jim, how's it going?
It's going pretty good. A little crazy, but pretty good.
Thanks a lot for taking the time to have this chat. I know that we just saw each other a couple of weeks ago at Synthplex, and you're probably getting ready to head out to Super Booth now, right?
Yep, I leave May 3rd, headed out there.
Yikes. That's keeping you hopping, it sounds like. That's pretty cool. Well, the last time we talked was way back in podcast number 38, so like almost 250 podcasts ago, which is like 5 years worth. So it's been a while. So you have a little catching up to do. So why don't we start off by just talking about what it is that has happened in the last five years for 512.
Well, the big news, of course, is that I've moved into hardware, specifically a Eurorack sequencing module. You know, I of course have been doing the software thing for quite a while. You know, we've all watched the Eurorack market explode over the last 10 years. You know, it was just a set of fortunate circumstances that came together. I was able to get into it, and I started shipping late last year. It's kind of a whole new ballgame in terms of my daily routine because it's not just software anymore. I have parts to wrangle and suppliers to work with and customers to ship to and the production process itself. And it's been a really interesting journey.
Yeah, well, it must be. I mean, if nothing else, you'd been working on numerology for a long, long time, but it had always been sort of I would say, an important passion project for you. The idea of pulling together faceplates and and nuts for connectors and stuff like that sounds like a little different thing.
Oh yeah. I mean, somebody can tell you're going to spend a lot of time working with parts and so forth, but once you actually get into it and realize, oh, I have to think about inventory, lead times and the cash flow and all those details, and it's several new skill sets, and it's not boring, I do enjoy it. It gets to be a little crazy sometimes, particularly because, there are 4 or 5 trade shows I try to go to every year. And those are things that once you commit to, the schedule has to accommodate.
Right.
It took a while to figure out, okay, I need like a 2-week cycle to build a set of vectors and the expander module that goes with it. And, I can do a certain amount in that time frame, and now I need to figure out how to shorten that time so I can spend more time back on software and working on that and getting better with it. It's almost a 180, I mean, when I started, I was mostly working on the Mac and I could work from anywhere, and now I'm mostly at home and I use Windows probably more than Mac right now. Certainly for the hardware, all the hardware development is pretty much in Windows. And I have all sorts of physical things to work with, parts and built products and products that are partially built, and it's quite the change, But we have a little saying around here: when things get a little crazy, this is what I wanted.
Yeah, be careful what you wish for, right?
Absolutely, man.
So why don't we have you introduce us a little bit to what this new hardware device is? You mentioned it's a sequencing tool. I got a very brief overview of it at Synthplex, but I'd really like to hear maybe a deeper dive on exactly what it is you put together.
Okay, so it's a digital sequencer, and it's in the Eurorack modular format. One of the interesting things about Eurorack is that when you ship internationally, it's not a completed product; it's a part, and that makes it much easier to get through customs control. And you also, you have to have a front panel and the circuit boards, but you don't have to have a case. So it was a pretty good choice in terms of a first hardware product. It has a selection of MIDI and CV/IO because I use it with Eurorack stuff and I use it with standalone stuff. It has a very straightforward control interface in the sense that it's 8 knobs with the display over all the knobs, so you can see all the values as you edit them. And then there are a selection of buttons above the displays that allow you to page through all the edit pages. So we have a page for setting the pitches, a page for gate times, velocity, and so forth. Below the row of knobs, there's a 1-octave mini keyboard, which you can use to program in sequences in a step record mode, or the buttons outside of record mode have different functions. So the white buttons can be used for things like skipping steps or muting them. There's a shift button, so you can do shift on one of the white keys to do operations on the sequence, like clearing it out or inverting it or generating a new one. It actually has 8 parts in it, which was a little surprising. I wasn't sure when I started building it how much I would be able to fit. How much memory does each sequence take?
Right.
How much CPU time is being involved? But it just worked out that 8 fit relatively well. There are a lot of things I like to do where I may use 2 or 3 parts on the vector for essentially one melodic musical part. So I'll do the classic Brian Eno, Steve Reich trick of having 2 melodies at different lengths. Say one is 5 steps, one is 7 steps, and have those phase against each other through the same instrument, maybe a piano or a polyphonic synthesizer. And we found it to be surprisingly useful to use the vector as a drum sequencer. So you spread out among 4 or 5 parts. And there are some chance operations where you can introduce fills and variations in the pattern. So having 8 parts has turned out to be very useful. There's also a pretty good selection of chance operations, which the way this started is in numerology. In the main note-based sequencers, there's a set of sliders for a random jump, so the probability the sequence will jump to some other random step, and then also whether the sequence note will sound at all, so basically a probabilistic mute. And I was trying to figure out how to pack those into a hardware UI, and it didn't seem right to have one page for each of those, and I was kind of interested in doing more than just those options, so I went with a page where you pick some operation you want, say mute the step, skip it, jump, do a random jump, maybe random jump forwards or backwards, maybe alter the pitch. So you set an operation, you set the probability that it will happen, anywhere from 0 to 100%. And then a third parameter is a bar restriction. So only happen every even bar, every odd bar, every third or fourth bar. So that's the trick for making fills. So that's something that it came out of trying to translate a software feature into hardware in a way that would be usable from the hardware standpoint, and then actually ended up expanding it quite a bit in terms of capability. And what else is on here? At the very first public showing, which I think was 3 years ago or so at NAMM, I didn't have an expander module. And then after that, we added the expander module. It gives you a lot more CV. It also gives you full-size MIDI connections and DIN sync, and also some triggers, a bunch of 8 triggers. I'm hoping to add a drum mode to one of the parts at some point, make full use of those sequencers. Those triggers. Yeah. So it's for me, it turned out to be a fairly complete translation of numerology into hardware, to the extent that you can get it to fit. Each part also has 2 sub-sequencers. So these are simplified, shorter sequences from the main sequence, and they can be used for modulation, or you can send them out one of the CV outputs. So you say you have a sub-sequence running at a different rate than the main sequence, and that's used for, filter cutoff or something like that. And that's very much a numerology trick, right? Having one sequencer modulate another. Right.
Now, so let me ask you to define something for me. You call this device a vector sequencer. What is your use of the word vector in this case? Why are you using that word in particular?
Well, it's several names in a pile, and this one stuck. The reason for having that name in the pile to begin with is that, I was trying to come up with a naming scheme, right? And I didn't want to call it numerology because that might give, I wasn't sure at the time how much like a numerology it would be.
How much you could put in it, right? Yeah.
Yeah, how much I could put into it. In mathematical terms, a vector is a set of numbers, right? So if it's coordinates, it could be X, Y, Z.
Mm-hmm.
And internally, the sequencer uses a vector of numbers. So for every step, you have a number for pitch, one for gate time, one for velocity, one for timing adjustment, I call groove, one for glide amount, the chance operation. So there are probably, I don't know, 20 or 30 numbers at any particular step that are essentially the coordinates for that step. And so that's your state space. And then the sequencer algorithm essentially interpolates between them, right? You generate the pitch values, you start a counter for the gate time, all these other things are happening. So it's, in that sense, it's a mathematical theme. One of the ironies of picking that particular name is, there's been a big resurgence in synthesis, and especially digital synthesis,
Right.
Algorithms from the early 80s. So vector synthesis is something that's started to come back. And I have the great honor of having a Prophet VS on a table nearby, loaned to me by a friend. And I'm going to be trying that out just to get to know it, But
Sure.
so the name is a little bit of, there's a basis behind it, and there's also a bit of chance behind it, I guess.
Well, it's a good word too, because for a lot of people, the idea of a vector also implies some sort of movement or directionality, which is a good implication to have on a sequencer anyway, right? So now you talk about having like 8 parts, but when I look at the device itself, what I see is two primary pitch, gate, and velocity outputs. How do the parts map to voices that a synth would use?
So nominally, you have 8 monophonic parts and 2 sets of analog outputs. So for each one, you get pitch, gate, and velocity. I struggled a little bit with the name of that third one, velocity. Should it be velocity? Should it be accent? And in analog terms, it would be accent or some kind of generic CV. But
Right.
because the sequencer works equally well with MIDI, I went with velocity because that's directly what it maps to on the MIDI side of things.
Got it.
So on board, we have 2 sets of analog outputs, 2 sets of MIDI outputs on TRS jacks, and there are adapters included, and also USB. So we have both USB-A for plugging in a keyboard or a synthesizer, and a B port for going to a computer.
Oh.
And so the nominal mapping is just parts 1 and 2 go to the 2 analog outputs, and then there's a routing page, and you can go to any of the MIDI outputs. And there are basically 8 slots or positions, and each one you can say, slot 1 is part 1, MIDI channel 1, slot 2 is part 2, MIDI channel 1, or maybe it's MIDI channel 2.
Got it. Okay. I see. Oh, that's really powerful.
Yeah, so there's kind of a nominal mapping. The analog outputs map directly to the parts, up to the first 6 parts. And then the MIDI outputs, all 4 of them can carry, actually 5 of them, because on the expander there's 1 more MIDI out. So all of those can carry all 8 parts, or just, which ones you select.
Subset. Interesting.
So usually what I set up is the first 2 parts tend to be monophonic analog. The third part I send to the Minotaur on MIDI and use that for bass. The fourth part is kind of a ad hoc. I may use it for modulation on one of the other parts, or just leave it blank. And then the last 4 parts, I'll either split between 2 polysynths or send them all to 1 polysynth.
Right.
Or if I'm doing, this is the setup I used for a little local gig we did last weekend, and where I'm doing bass lines and textural stuff. If I'm doing more percussive stuff, I'll usually take the last 4 parts and send those for some sort of drum pattern.
One of the things that I think is really interesting is this concept. I mean, I have to admit that until you started walking through your setup, I wasn't even mapping how this could work, because I am stuck in this idea that the modular is at the end of some sort of control system, right? That you might have a computer and a MIDI to CV converter, you might have a standalone sequencer, or like one of the pyramid things or something like that, and somehow the modular is sitting at the end of a line as the recipient of stuff. I have to admit that I hadn't really thought of the modular being sort of the work center and you being able to kind of like spin stuff out from that. But now that I'm seeing this, the dual, I'm looking for on your site, on the 512 site, you've got the picture
Hmm.
right on front, and I'm seeing sort of like the strip of connectors on the top. It's like, oh yeah, there's the two MIDI connectors, there's the USB. I hadn't even thought about the USB as being routable, as computer control things, but also the dual MIDI. I mean, literally, you set up a system here that it can be the central work spot and sequencing system, and you spider out from there.
Yeah, certainly. I mean, that's how I use it. I know people that use it as, this is specifically for bass lines or
Uh-huh.
this is for some chance operation
Hmm.
stuff. But it was one of those things where, when we're figuring out what to put in it, one of the obvious things is like, hey, this could eventually be a really nice controller for numerology. So, okay, well, we're going to need a USB MIDI connection for that.
Right.
And it has an SD card. And at the time when we first started putting it together, we didn't know where to find that magic vertical SD card connector that everybody's using now.
Hmm.
So we just put it on the back, and the idea is you hold down a button and connect it to a computer, and you start up, and the whole thing becomes a giant thumb drive.
Right, right.
So, and that actually works really well, really convenient, instead of like pulling the card out of the slot, find the
Yeah,
adapter, find the
right,
other adapter,
right.
So that was the USB B port. And then
Interesting.
the
Yeah.
USB A port, originally there was a regular TRS MIDI input. I didn't want to really deal with two USB connections and all this other stuff. And then I started, the idea is if you want to program in a sequence from a little controller keyboard, that's what the MIDI input is for.
Right.
And then I started looking around at controllers and realized,
None of them have MIDI ports
80,
on them anymore.
yeah, 80% of them don't have MIDI
Right,
port at
right,
all.
right.
Right? So it's got to be USB.
Yeah.
And of course, I have a big stack of launch pads, and using a launch pad as a secondary controller for this could be kind of interesting. So
Hmm.
I was like, okay, we have USB-A on there. And, and always from the start, I was like, okay, I want MIDI and CD. That was never, that was
Right.
always there. So yeah, and, something I'm looking in, again, personally is how can I make it a better way for routing MIDI from a controller? So,
Sure.
I decided, okay, I need to be able to start playing gigs out again. And I can't play keyboard for shit, but I like having it as a controller and for entering patterns or transposing things. And you can use the keyboard on the unit, but it's still better if you have 2 or 3 octaves. So,
Right.
I'm kind of looking to like, okay, I want to have a way to quickly have the keyboard MIDI go to a synthesizer so I can just play the synthesizer straight up, or I want to split it and have the lower half transpose one part and the other half transpose some other part. So that's something I'm kind of looking into. And so, yeah, I mean, from my perspective, my own personal use, it's kind of the center for composition, and it's a pretty good way to, get yourself to use something, right?
As you started getting more of numerology inserted into this device, you must have also simultaneously come to realize that it had to be different from numerology. I mean, if nothing else, one of the things I love about numerology, I've been a user for ages. I love this software. But a big part of it is because it is visually easy to grasp. You can get in there, you can see
Mm-hmm.
what's going on, you can make your adjustments, the whole thing lays out. So even if you're an occasional user, you can come back and feel like you're immediately diving in. And even things like having modulating sequencers, modulating other sequencers and stuff, the interaction of that is relatively straightforward because it's highly visual. When you're working with a piece of hardware, you almost have the opposite thing. You have to focus on making a system that can respond to muscle memory rather than some kind of visual memory.
Yeah, I think that's a very good point. And then just in that general area on hardware design is you can't just add another menu or window somewhere, right? Everything
Right.
has to fit on the physical controls you have. And the real challenge isn't just giving people, intuitive controls, but keeping track of where you are.
Right.
And particularly with something like this where you have, so many different potential pages you can be on and working with different parts. very early on, I started with, I knew it was going to be a display and 8 knobs. So I wanted a short, very wide display. And I was looking at 40 character by 2-row displays.
Mm-hmm.
And they're nice. They're really cheap. There are a couple problems. One is they're physically always, they come with the display in a metal shroud on a circuit board, and they're standardized. So they're always the same size, and they're really quite bulky, particularly in a Eurorack where you're, a little over 5 inches is your height limit, period.
Right.
So I started digging around and found OLED displays and got a couple that, they just happened to be the most expensive displays in this particular catalog, but they're the perfect size and they're very high contrast. And another problem with those 40 by 2 displays is they're generally character only. You can add a few characters, but they're not bitmap addressable.
Right.
So these are bitmap addressable. So it was, like 2 days in playing with one, I'm like, okay, it has to be this.
Yeah.
So that became a big part of the UI. And the advantage there is, in terms of keeping track of where you are, I try to make every edit screen look really different from the others. So, pitches are generally note names. Gates are one kind of a horizontal graphic. Velocity is a vertical graphic. So it isn't, there's the muscle memory. Yeah, that's definitely part of it. There's.
So you're saying there's still a visual memory aspect in the way that you designed it too.
Oh, absolutely. Absolutely. I learned that doing the launchpad mapping for numerology, was that because you have so many pads and they're all colors and you can use different colors, is okay, on the launchpad, the color and to some extent the graphic layout is the key of where you are.
Mm-hmm.
And on the vector, but the screens, the graphics for the values are how you keep track of where you are.
Mm-hmm.
And then for different parts, I change the color on the LEDs. Although occasionally I do get, like, wait, which part am I on? So that's something I'm still working on, just making that a little more clear.
Right. Well, the other thing I noticed, and again, you can see this right on the front page of your website, is the way that you're able to kind of make a fairly dense amount of information in a small area. Because one of the issues that I think could be a real problem, and it even in a way is a little bit of a tough sled when you're working with numerology proper, is the sense that you can have depth that's greater than what you can see, right? Which is that, like,
yes,
you can have, like, on the part of the note sequencer where you have the repeats and the gates and all this kind of stuff, right? There's depth there that you can't necessarily see, so you have to kind of switch modes. One of the things I noticed you're able to do on this is imply things like slides and, octave orientation and stuff like that by using just like some simple iconography, because you are able to bitmap or display map whatever you choose to do.
I try to make sure that all of those symbols are as straightforward as possible and use different fonts, different sizes. And some of this comes from doing some iOS development a while back, is, and you get it just from using the phones, is, that there's the classic cheeseburger button, right, which is just 3 horizontal lines, and there's, this kind of mnemonic people have, okay, that's a menu. So it's like, okay, how can I use simple graphics to, indicate these things? Kind of, it seems obvious now, but a personal breakthrough at the time was for the chance ops, I wanted to have circles. I wanted to have a circle around the value that would show the probability of the probability amount, right? So you could have a little symbol for the operation and then the circle around it for the probability. One of the interesting things about moving from a big OS to embedded hardware is there's essentially no OS. You have, if you want USB, you load the drivers for USB, but you have to do a lot of the work of the communication yourself. If you want, the SD card, you have the SD card drivers and then the fat file system stuff, but you still have to, do a fair bit of the work there. For the displays, you get some driver code and it reads and writes the displays and it can do basic character stuff. But if you want to draw graphics, well, you're now writing, certain areas of memory. It's an ancient algorithm called bit block transfer. On the Mac, you don't do that, right? You just say, draw this image here with this size.
Right.
So on this, it's like, okay, I wrote my own little bit block transfer. And it's not difficult, but it kind of, it kind of clarifies your options in a way. It's like, oh, if I want to draw this circle, I can just, use a font program to generate the bitmap files.
Right.
And then writing those is the same as writing characters. You're just copying memory from one location to another.
Yeah.
So it's like, oh, okay, a lot of these little graphic, like the little glide symbols they have on there, right? So if there's no glide, there's nothing. But if there's a little bit of glide, you get a straight line with a little tip on the end that's rising or dropping, depending on whether it's going to go up or down. And then if it's 100% glide, it's a horizontal line. Well, drawing angled lines using a bit block transfer is a fair bit more complicated because the displays it's 4 bits per pixel, so you get 16 shades of gray. And there's a relatively complicated mathematical thing that goes on when you try and anti-alias a line. Unless, of course, you draw it somewhere else and just use the graphic. So all those little glide symbols that's actually a little font with, 16 different characters.
I see.
And that works great. I can spend, an hour or so designing the quote font.
Right.
And it generates it into C code, and that gets loaded, and then just use the same commands you use to draw characters. It's just such a different approach from working on a full-size computer,
In a way, though, it's almost like going back to like late 80s, early 90s style programming where you had such limitations that finding the appropriate workaround was a big part of success, right?
Yes. And I mean, and all, memory limitations, CPU speed limitations. My first computer was a 128K Mac. I still have it in the garage somewhere. And this one has a much faster CPU, but it's, I think it's 192K of RAM.
Yeah.
So yeah, it's very much Back to the Future. I mean,
yeah, you probably thought you were never going to have to deal with bit block transfers again in your life, right?
No. I mean, it actually took a while to get. The interesting thing is that a lot of the code that's in here is from Numerology. So it's the same sequencing algorithm. It's a new storage algorithm in terms of parameters, but it's still based on some other code. And the code compiles and runs on the Mac just fine. But in terms of the mindset on how you use memory and storage and, how you select, if there's going to be a new parameter, it's like, okay, exactly how many bits do I need to store this parameter? There's an extra bit of work because I'm an object-oriented guy, right? I like high-level programming. So there's an API that hides the fact that, skips are a bit and repeats are 3 bits and that sort of thing. But there was definitely a transition. Initially, I just moved a fair chunk of the numerology code to a chip, and it was taking up a lot of space, and I thought I'd have to have external RAM, and initially I was like, well, this will work, this will be fine. And then I kind of backed up a bit and looked at it and said, well, I don't need that much space. This is ridiculous. I don't need a 32-bit float to store the pitch value, right?
Sure.
And so, there was definitely this part. It's like, I knew how to deal with bits and bytes. I did all that, and so it went from that, and then another weird thing, you don't quite realize at first when you get into this is if you can have external RAM from the microcontroller, but it's not that big, and it's also generally quite a bit slower than what's on the chip. So the chip has, a CPU, and it's got all the peripheral hardware for things like SD and USB, and it's got some flash, and it's got some RAM. And the RAM that's on there is very fast. It's not much, but it's very fast. On a desktop, you get a computer with so many gigs of RAM, and these days you don't even remember that there's an L2 and an L3 cache, right?
Right.
3 levels of caching and multiple processors and all this very, very sophisticated cache coherency stuff going on, and it just seems like you've got an endless amount of really fast RAM.
Mm-hmm.
When you move to embedded hardware, those assumptions just don't hold anymore. And it's kind of, any of the hardware guys are reading this are like, well, yeah, of course, but again, coming from the desktop, it's like it takes, a little while for that to kind of sink in terms of changing how you want to write the code.
I think that's really an important thing, because I think there is this assumption right now that, whether you talk about the system on a chip setups or some of these other processor bases, that, at this point, a software guy can walk into a micro center, get a system on a chip, walk home, and, make their next hardware piece tomorrow. And the idea that it actually is a very different world isn't very often discussed.
And I think, when I came in, something like a Raspberry Pi as the engine,
Mm-hmm.
right, was an option. And, you did a project with Arduino, right? And that's very much a microcontroller, even though they have a desktop style IDE for it. It's still a microcontroller. You still have all those hardware things.
Right.
And I really do think it's important for people doing software to appreciate, well, the joys of not having operating system updates to deal with, or some of the things that seem annoying at first in terms of, how you lay out memory access or the stack size. And, you can, I use a little threading library called FreeRTOS, is that, once you kind of get a hold of these things and how they work, you have a lot more control over how you build the system, how the system interacts with the hardware. I don't do very much what you call bare metal programming, where you're writing directly to registers.
Right.
There's always there's always this relatively thin layer of driver code in between, but you're still conscious of all the hardware stuff. The alternative is you work with the more increasingly available chips that are, they're basically running a Linux or a real-time Linux kernel, or a modified Raspberry Pi kernel. And someone might tend to guess that, me coming from a desktop system would automatically gravitate to that. And I looked into it, but I was also, it's like, well, I'm kind of having OS fatigue.
Right.
I don't want to have to worry about the virtual memory settings. There are some things about Linux that make it more difficult to use in an embedded system. You basically, the OS has to be tuned for it. It took a while again. It's like the whole transition in terms of thinking about external memory and having lots of memory versus, okay, what can I do in this amount of space? The OS thing is the kind of the same transition as, I'm used to having this comfort zone and all these APIs and not having to do all these things. And now I'm like really happy. I can just write my own bit block transfer, and I know exactly how the code works, and if there's a problem, I can actually go in and fix it. And
fix it. Right.
Nobody's going to change that code underneath me unless I'm using a driver and update the drivers. And even then, you still have all the source code.
Right. Well, and I just think, on the desktop side, the sort of like ever-changing world of like, well, we're going to sandbox you out of this, or you have to be properly signed with this, with Apple, otherwise, we're going to put your users through a hellhole, right? I mean, all that kind of stuff.
Right.
In this kind of environment, it doesn't exist because you maintain the control of it all.
Yeah, and I think most people don't realize it's just as it's even more frustrating to developers than it is for users, right?
Right.
And I think this is a part of the reason people have migrated so much to hardware is, on the desktop you have essentially an endless series of updates to work with, and you can't even avoid it anymore. I mean, some people will say, oh, my Pro Tools system is hermetically sealed, and then a week later they're like, oh, I really want this new plugin.
Yeah, right.
Like, well,
right.
That plugin requires, all these OS updates, and now you got to update everything else. It's this big tangled mess.
Yeah, even worse, you have the scenario where it's like, oh, they finally fixed this. Oh, in order to take advantage of the fix, I have to update everything, right?
Right. So many of us spend most of the day at a computer. When you get time to be creative, well, it used to be great. You could be in front of a computer, right? I mean, you could get all these things done you couldn't before.
That's right.
Yeah, it used to be really, and now it's still a critical studio tool. It's still essentially the center of everybody's studio. But if you just want to sit down and noodle around and make something, people tend to want to use hardware now.
Yeah, true enough. Well, so now that we've bridged, though, the discussion of the desktop, I mean, you made your bones on the desktop, and there are still a lot of people for whom numerology represents the way that they like to do sequencing. Is this going to replace numerology? No,
this is a complement, and it's, I think, going to be a really good design influence on it. So as we discussed earlier on hardware, you really have to focus on the organization so that people can find things, people can remember where things are. And in numerology, partially because it's been around and I keep adding things, is it needs, some reorganization on the UI side. not necessarily at the high level, but more within a module. So, each module has a little semi-hidden panel where there are a bunch of little preferences about how things work, but there are also a couple things in there that are really, there's a button to double the length of a sequence. Well,
right.
on the vector, that's an operation, and there are essentially operations global to a sequence, like shifting it left and right or generating a new sequence. And then there are operations that are at the step level. And I can now going back in numerology and looking at the layout and the design of things, I'm like, okay, I should be grouping all the operations into one area, and and changing out the step probability and the random jump things and redoing that as a chance thing. And now that I've had this experience in a more limited environment, meaning that on the hardware, it's like, I really need to know if this node has glide on it. And then going back to the desktop, which is a bigger problem to solve, it's like, okay, I should really start thinking about having, small little graphics wherever I can to say, there's a chance operation here. There's a param mod going on here. So it's kind of one of those things where you have to get away from the bigger problem and go to work on a different area and a slightly different problem. And then you can come back to the big problem with fresh eyes.
Right. The domain shift literally helps you reimagine how you could do it. Right.
Yes. And it's ostensibly the same code base. There are a lot of little bits of code that are exactly the same between the two. There are the sequencing algorithm is essentially the same.
What's the biggest thing missing from the hardware?
In the vector?
That's in the software.
One thing that's missing right now is the sub-sequencers are only, it's just one value per step. There's a level. Oh, okay. In numerology, you can have a gate sequencer or a linear sequencer. And you can apply, separate sequencers for pitch, gate, and velocity, and then there's a module that combines those. And on the vector, the reason there are two sub-sequencers is eventually I can hopefully turn on a mode. One will be in a gate mode, and one could be, either any linear, like a triangle wave, a linear interpretation from step to step, or it can be a fixed step. And those could, with a couple settings here and there, override the standard gate and velocity lanes, which are always tied to the pitch lane, right? They're part of that vector. So that's there. Obviously, it doesn't host plugins. That's a big difference. Right. There's no audio. There's no audio system of any sort.
Right. That's actually a great point, because between the plugins and the audio section, that is one of the things that sort of allows numerology, the software, to act as like a standalone work environment, where this is obviously the vector is obviously the audio system is the modular that it sits inside of, right?
Right.
Very interesting. So what you talked about, this expander, is that already available, or is that something you're working on right now?
No, it's available.
Oh, okay.
I build and test them together. So, every vector is paired with some expander, and I test them together. Often they are shipped together with orders.
Oh, okay.
The expander's been very popular. Most people order them together, and many people come back and get one.
Sure. That makes sense.
And
well, because it makes especially sense because there's an awful lot of power here that seems like is sort of like begging to come out. So the expander would make a lot of sense. From your perspective, when you are playing, what's the facility that it gives you that you hadn't had with modular systems before that? Because you've been using modular for quite a while. And what is it that this, as an available hardware thing, gives you that you didn't have before?
One thing it's interesting because this is something I really like, but some people don't even really want, is actual note name displays.
Mm-hmm.
I want to be able to dial in specific notes. And there are some little tricks. You can hold down the shift key and twist an encoder and it'll jump by octaves. And, for certain types of, say, bass sequences, that's the first thing I'll do is I'll start with a sequence with all the fundamental tone, and then I'll start shifting a few of those steps up or down an octave, and then I'm working on another combination where I can go up or down in thirds and fifths.
Right.
And, and just being able to see the note names is something I really like. Presets are another thing. I like to be able to say, okay, I like this pattern. I want to get back to it later. So I'm going to shift preset to duplicate the pattern, and I just keep developing it. And then I can go back to the original really easily. Another thing I do all the time that would be a fair bit, it's certainly more expensive to do in Eurorack otherwise, is work with two parts that are going to the same synthesizer, to do basically ambient loopy things.
Uh-huh.
The chance ops have been a really popular item, and I'm using them more and more. So, you've got a pattern and you want it to be a little different every time through, but you don't want it to just be random, right? You can add a couple random jumps and a couple pitch changes, and so it'll vary a little bit, but it stays pretty close to where you started.
Right. Yeah, that's awesome stuff. I have to admit that you've got me really curious to want to spend some time with this, because it sounds amazing. And as a longtime numerology user, I mean, all these things, like when you talk about like generation, or you're talking about some of these kind of generative or chance-based operations. I mean, that is, to me, one of the things that was a real draw of numerology, is that you could kind of, you could use it like you did other sequencers, where you just kind of like grind out changes and listen to this step, and then, I'll change this, listen to that, right? But there was also this number of operations that you could just try. If they didn't work, they didn't work. But more often than not, even if it wasn't exactly what you wanted, it would spur you into a different direction that might actually make something that surprises and delights you in a way that might not otherwise happen, right? I think that's the thing I always loved about numerology, and it sounds like you actually built that into the hardware.
Yeah, as much as I could. I do a lot of free improv when I work with other people, just because, hey, come over, let's play, right?
Right.
So,
sure.
You got to come up with stuff. And, I don't play piano or keyboard, piano or guitar at all, really. I could play some, but I'm certainly not going to do it in front of other people. And, the nice thing, that's really how I got into sequencing, right? I like having it because you work with it and it talks back to you, right?
Right.
So you're like, let's try this. Oh, that's interesting. Let's do more of that. Let's try that. That's not so good. So let's go back, So it really can lead you in different directions that you don't expect.
Right.
And that's really useful in the kind of improv context, because you can try a few things, and, and then you've got the sequencer is talking back to you, and then the other performers are doing what they're doing,
Right.
So it's just increases the options for where you can go, without having to really think, oh, I want this to be more aggressive, or I want this to be more poppy.
Right. Sure. Yeah, that makes a lot of sense. So you are blazing away at the hardware. Do you imagine more hardware pieces, or are you just going to further try and refine the vector expander combination?
Well, there's definitely going to be a lot more refinement coming. There's a whole bunch of things I want. There are things that people are asking for. It's surprising how quickly people are getting into kind of the little hidden nooks and crannies and trying out relatively esoteric features.
Okay.
And but also, yeah, there's some new stuff we're working on, and we're still a fair ways away from announcing it, but something that complements the sequencer nicely.
Awesome. Well, that sounds great. And with the software, what do you have for the future of the numerology software? Obviously, it sounds like you're going to be taking some of the concepts and ideas that you have on the hardware are going to be coming back to the software. Do you have any particular plans in that area?
Well, that's all part of the Numerology 5 push. That will be a fair bit of it is just doing some reorganization of the UI so things are more logically co-located.
Okay.
There are also this kind of general trend that I started with the release last summer or so, where there, again, in a way, it's a way of combining different features. So it's like this general idea of you've got a keyboard, a MIDI keyboard, and you've plugged it into the computer, and you're going to use it to basically control a sequence somehow.
Mm-hmm.
So what are all the interesting ways you can use a keyboard to control a sequence? And the simple one is to transpose it, or you're going to do step recording. But arpeggiation is a big thing. So I've come up with some interesting ways that you can hold down chords on a keyboard and have either basically you write an arpeggiator into the sequence that you can then edit, or you've got a sequence and you hold down keys and it basically repitches the whole sequence, which actually is in one of the more obscure numerology modules, the matrix sequencer. And it's, again, that one is a little complicated to learn how to use well, but it lets you write essentially an abstract pattern and then you assign the notes on the fly as you see fit, by playing a keyboard.
Okay, I got it.
A lot of these things you can do now in numerology, but they're really separate workflows. Step recording is a little bit different from transposition. So I've been trying to combine those so it's more logical. It's all in one place.
Right.
You can control remotely which mode you're in, navigate from one sequence to another, that sort of thing.
You mentioned very early in our conversation that now you're doing a lot more work on Windows. Any chance that some version of numerology might be made available for Windows users? He says hopefully.
Yeah, I say hopefully. It's a lot of work, and it's not just the code, it's also testing and support. On the Mac, the audio APIs, like there's one, and it's pretty consistent how it works from hardware to hardware. Windows, it's like, okay, so what audio API is everybody using? Oh, okay, the same one they were using 15 years ago.
It's a bit of a crapshoot.
Yeah, it's going to be C++. What graphics API do I want to use? And that's not an easy choice because you don't necessarily want to use someone else's graphics API because then you're very much tied into what they're doing and what they're not doing, right? Right. So that's been kind of a major decision point. And right now I think I'm at the kind of a thing where I'm just going to write, again, something revealed to me in the hardware. It's like, you can get to do a lot with just bit block transfer, basically just drawing images. So now it's more like, okay, well, what if I just do that with OpenGL and have some stuff on top of it?
Right. Interesting.
I don't necessarily need all the bells and whistles you get with a full GUI API like Cocoa. And, and there's been a little bit of coding in that area, but it's just the whole product thing is, well, I could say I'm working on it, but then people are like, well, I want to buy it now,
Right.
And it's like, well, no, and stuff happens. So it's definitely not because I don't want to do it or, and I can't, and somebody will email me and say, well, why don't you just use Juice? It's like, well, except that numerology already has, half of what Juice has. And I'm not going to pull that stuff out. There are decisions in there that's what makes numerology different. So I've been doing this for quite a while, right? And, how many little tool sets have you seen come and go or, they're still around, but they haven't been updated for some new hardware or,
right.
And
I can really appreciate that. I appreciate not wanting to necessarily buy into someone else's idea of what's important and what's not. That's a real critical decision.
Yeah.
Well, Jim, it's been great to get caught up. It's really great to hear. I mean, it's obvious you're really excited about the vector sequencer. It looks like an amazing piece of work. But it's also great to hear how it's kind of turning into sort of a big ecosystem of sequencing for you, and one that's going to affect numerology users as well. So that's really exciting. Is there anything else you have coming down the pipeline that you want to talk about?
Nothing yet.
Okay.
There's going to be updates coming for numerology and the vector, and they're going to be going to Super Booth in a couple weeks, and then NobCon in Chicago, and then not sure yet about NAMM, but Synthplex was great. I look forward to going back. And I certainly encourage anyone using the Vector or Numerology to come by and chat. I love hearing from people about they're using Numerology. You know, they love these features. They need some changes, or they like, you know, a different, you know, so a few workflow differences. I love getting feedback from people. It's so easy living in a quiet little town in the Southwest that, you know, you get kind of just, you know, it's like I say, it's like I'm going to crawl under the rock and write some code, right? So it's so great when somebody emails me and says, oh, I was doing this. Here's a track I've been doing. Or, you know, just going to keep chugging along here.
It sounds great. And for anybody who wants to check it out, 512, that's FIVE, then 12.com is the place to go, right?
Yep.
All right. Awesome. Well, man, I want to thank you so much for taking the time. This was a really great chat. And we'll catch you again soon.
That sounds great. Thanks for calling.
All right. Bye. Many thanks to Jim for having another round of chats. Really interesting to hear about his new sequencer and the way that it kind of integrates with the ideas behind numerology as well. It's clear that this is an idea that's been germinating for a long time, and it's great to see all the different results from it. If you want to check it out, make sure you go check out 512.com. And I want to thank you all for continuing to listen. Back at home, everything's nice and safe and warm. I'm starting to get rested up again. Looking forward to the next thing, which is actually a performance here in the end of May. So in any case, keep in touch. Let me know if you have any questions, comments, concerns. And with that, I let you go. Bye.